Hey there. So in this short video, I'm going to walk you through a tool I built that allows users to compute for the compressibility factor of gases, to calculate for the enthalpy departure term, the entropy departure term, the internal energy departure term, and also allows users to compute for the heat capacity at constant pressure. So compressibility factor is basically used to correct ideal gas law for real gas behavior, and finding for the compressibility factor for for substances using equations of states like Van der Waals or Peng-Robertson can be really tedious and prone to errors. And so these two automate all those tasks and make sure that users are efficient and also less prone to errors. And so let me quickly walk you through the interface of the function or app so that you see how it works. So I'm going to share my screen so that you see the app's interface. So this is the main interface of the app. This is the interface for the specifically for calculating compressibility factor, the internal energy departure term, the entropy, and all those stuff. So these are the inputs. So since there is a demo, I'm just going to use a fake data to show you how the whole thing works. So let's say we are computing for the compressibility factor in internal energy departure term for a gas with a temperature with a pressure of say 100 bar. You can also select which the kind of units so that we'll do the whole conversion of units. You don't have to do it yourself. So 100 bar, and then we are choosing a temperature of 900K. And here you can choose to work with the specific R or universal R. So for this demo, we are going to work with the universal R, and you choose your equation of states. So let's say Van der Waals equation, and then you can select your compound to, and then the function will autofill these properties of the compound. So if you select, say, let's say I select methane, I search methane and then I come and select it here. It will autofill the properties. So this is the critical temperature of methane, which is 190.4 Kelvin, and this is the critical pressure. And we can choose to either directly input A and B, or we can work with PC, and the eccentric factor. So, and here you can specify whether you want, whether the substance is in the liquid phase or it's in the gaseous phase. So for this demo, you are going to choose um, gaseous or gas. And here you can specify which type of computations you want to do. So you can add either calculate for the Z factor and enthalpy departure term, or the entropy departure term, or the natural log of fugacity coefficient. Yeah, those are the four different computations you can do. So for this demo, we are going to choose Z factor and enthalpy departure. Hit on your calculate, and then it outputs every parameter you need to find in calculating for your compressibility factor. So it finds your reduced temperature, your reduced pressure, your the parameter A, that's the small a, the B, and then the dimensionless A, the capital A, and then the B. And then it uses those parameters to compute for the coefficients that will be used to find the compressibility factor. So here is our compressibility factor, and um, the computing for the specific volume comes with the compressibility factor as default. So whenever you do a compressibility factor computation, it's automatically computes for your specific volume. So here is our specific volume, and this is our enthalpy departure theorem, which is negative 6.380. This is a dimensionless one, and this is per kilomole, right? So this is basically what the Z factor does. You can just use the same values to find your entropy as well, and then we'll compute for the entropy. So here is our entropy. You can use it to find, if you want to find lane fugacity, you just click lane fugacity and then you find it. This is the natural log. And let's move on to the CP heat capacitor constant pressure interface to see how it also works. So here, similarly, you can search for your compound. So let's say methane, and then select methane from the drop down. It automatically fills the parameters for you, right? Everything is in the background. So we have a table in the background that the function searches, and then looking at the compound you choose, it will find the parameters and autofill for you. And so after selecting, you can choose whether your upper limit term and then the lower limit term. So we are using the defaults 250 and 350. Let's see. So here, this is our heat capacity per kilomole, right? So yeah, that is those primary or main features of the app. There are other features that I will leave you to explore. Thanks. So yeah, those are basically the main features. Thank you for your time and attention.